This is section 2.5, day 2, and today we're really going to get into proofs. Yesterday we were doing a little bit of algebra stuff, and today is really going to move into segments and focusing on how to prove things, how to construct a geometric argument. So we're going to be able to prove statements about segments today, and we need to go to the theorem card and kind of finish that up. Again, I'm not sure about the exact order. You might have a slightly different card than mine, but we need to do segment addition postulate, which is the sum of the parts equal the whole thing. This is like we've done before with part plus part equals whole. So what can I say? I should be able to talk about the whole segment and its parts. I should be able to break that down and come up with some kind of statement to say. Definition of midpoint, it cuts a segment in half. So definition of midpoint would be our abbreviation, and then we should be able to say that two segments are equal or congruent. So if I have a segment and I know the midpoint, cut it in half, I should be able to talk about these two segments that are now equal to each other. Last one on the front, definition of bisector, same thing. Cuts an angle or segment in half. This is how you're going to abbreviate it. I'm having trouble talking today. And it's going to be the same thing. You should be able to say that two things are equal or congruent. Could be angle pieces, could be segment pieces. But you should be able to tell me about two things that are congruent. On to the back, we've got definition of perpendicular lines. So two lines that are perpendicular make 90-degree angles. So you should either be able to tell me about two angles that are, I suppose it doesn't have to be two. You could be able to tell me that two angles that are 90, or you could be able to talk to me about lines that are perpendicular. You could kind of do one or the other. Angle addition postulate is the same as segment addition postulate. So it's still going to be part plus part equals whole. This time it's just going to have to do with an angle and not a segment. So you should be able to talk to me about two things that are equal. Sorry, two things that equal the whole thing. Linear pair postulate is just talking about those two angles that make a linear pair and that they're being supplementary. So you should be able to say that angle plus angle equals 180. You should be able to make kind of an equation out of it. Vertical angles, so you should be able to, by the end of that, be able to tell me which two angles are congruent. So you should be able to say that an angle is congruent to another angle. Definition of complementary angles. This is two angles that, excuse me, that add up to 90 degrees. So you should be able to make a statement for me like angle plus angle equals 90. Definition of supplementary, same thing, only this time they're going to equal 180. So I should still be able to talk about two angles and then equal 180. Definition of right, so right angles are 90. You should be able to tell me that some angle equals 90 degrees. All right, so let's go try a proof. So the first one says that we are given that AC equals AB plus AB, and we're going to prove that that segment equals that one. Okay? So they're talking about AC equaling AB plus AB. This is our given statement. You always have to start with a given. Just like yesterday when we were doing algebra, your first statement is always your given. You got to start somewhere. After that is your proof. So statement number 2, I think I want to talk about how AC is made up of these parts, these pieces. They talked about AC being one piece repeated, AB and AB. I'm going to talk about it being AB plus BC. How it's these two segments put together equals the whole thing. And that's called segment addition postulate. Part plus part equals whole thing. Now that both of these are equal to AC, this is like the transitive property or kind of like the law of syllogism where I can cross off the overlap and make these two equal to each other. So AB plus AB equals AB plus BC. So I took that, put it there, I took that and put it there. They were both equal to AC, so I could kind of get rid of the overlap and make them equal to each other. And that's called substitution. You could also use transitive. Either one of those two will work. I'm trying to get it to be AB equals BC, and I've got an AB right there. I got my equal sign, and then I got my BC. So what I need to do is get rid of that. So I could kind of subtract an AB from both sides, and as soon as I do that, they go away. And so I'm left with AB equals BC. And we used subtraction to get there. And that is your first proof. So your job is to be able to go from the given to the prove talking about the picture and moving your way down. These are not easy. I will tell you this, though, and I'll repeat it a lot. You have to keep trying. You have to keep going after something. The given statement is always first, so you should be able to write that down. The thing you want to prove always comes last, so you should be able to get 3 points on a test. The stuff in the middle might be a little sketchier, and it definitely takes a lot of practice in order to be able to do these. We're going to do another one that looks a lot alike, but we're just going to attack it in a different way. This time they're going to say that M is the midpoint of AB. And I put that down as your given. And to give you some help, I filled in some of the statements or some of the reasons, the justifications, and you're going to come up with the statements. So if I know M is the midpoint, and given if we looked at our theorem sheet, definition of midpoint just says then that I should be able to say that two segments are equal. That's what I should be able to say. So since M is the midpoint, I should be able to say that AM is congruent to MB. They are congruent to each other by definition of midpoint. Midpoint cut it in half, and that means that guy is equal to that one. Next it says segment addition postulate. That just means part plus part equals whole. So they want me to talk about two pieces equaling the whole thing. Well, that's easy. Here's my two pieces. There's my whole thing. So AM plus MB equals AB, equals the whole thing. This part plus this part equals the whole thing. Substitution. They want me to substitute somebody. Well, the only thing I have that are equal is that AM equals MB. So let's substitute and put it in there. So instead of AM, I'm going to substitute what it equals. Whoops, I want to go the other way. Sorry, I didn't look down here. So AM I'm going to put right there. I want to aim for two AMs. So I want to get rid of the MB. That's not what I need. So I'm going to do this AM plus another AM. All I'm doing is taking MB and I'm substituting it for AM. So I'm putting that right there. Equals AB. I substituted. And now I've got two AMs together equal AB, and we simplified. So a lot of the proofs you're going to do with me are going to have some pieces filled in, and you're going to have to come up with some of the other pieces. Let's try another one. So the given is always first. That's the easy part. Given. This time I'm going to give you statements, and we're going to try and come up with the reasons. So the first statement says AC, this whole thing, is equal to AB plus BC. Well, that's a part plus a part equals the whole thing. So that's segment addition. I'm taking two pieces and adding them up to be the whole thing. That's segment addition. Next one, they did BD, this one, equals CD plus BC. Well, that's the same thing. They just are doing it the other way. So segment addition postulate. They're taking two things and breaking it up into its parts. BD, okay, they copied that. They kept the BC, but instead of CD, they took that out and put AB in its place. That's because they're equal to each other, so what they did was substitute. And then to move from there down, this will be tricky. I have an AB plus a BC. I have another AB plus a BC. This one happens to equal BD. This one happens to equal AC. So since they were equal to the same thing, they both had AB plus BC, that means they must be equal to each other. It's kind of like saying A equals B and B equals C. I can cut out the overlap and jump to these two. So for these two statements, I can cut out the overlap, and these two have to be equal. And that is substitution. You can also use transitive. Either one of those will work. I will say it again. Proofs are not easy. They are not easy. They are one of the hardest things for kids to do because there is no right answer. If I didn't put these steps here, you could have solved it a different way from your neighbor. And when you're doing these, start with the front. Start with your given and your prove, and try to see if you can fill in the middles. Like I said, for most of the proofs you and I do, you're going to get some of the steps along the way, and you just need to figure out the reasons or the statements.